Monitoring Wi-Fi networks with airodump-ng. Welcome to Wi-Fi Challenge Lab. In this video, we will see how to monitor Wi-Fi networks using airodump-ng. The first thing we need to do is put the interfaces in monitor mode. To do this, we first open the terminal and elevate the privileges to root to avoid using sudo constantly. We can list all interfaces with the command iwconfig, where we would see all the interfaces along with their information. There we have them. We can also use airodump-ng directly to list available Wi-Fi interfaces in a much simpler way. Here we have them, from 0 to 6. And we can use any of them since they are all the same. Let's put the monitor mode. This can be done manually or automatically with airodump-ng. First, let's do it manually. Before starting, it is recommended to stop the network manager to avoid conflicts with the interfaces. Then we deactivate the interface with the command ip-link set VLAN 0 down. Next, we put it in monitor mode with iwconfig. After that, we reactivate it the same way we did before, but with up. With this, the card is now in monitor mode. We can verify this by getting the information with iwconfig for that specific interface, where we can see that it is in monitor mode. To remove monitor mode, the process is almost the same, but configuring the mode to managed with iwconfig. If we run iwconfig again to get the information, we can see how the monitor mode is removed, and it returns to the default mode. Now let's do the same with airodump-ng, which is easier, although some Wi-Fi interfaces may cause problems with this method. Therefore, in real life, it's more recommended to do it manually. To do it with airodump-ng, you simply need to type start and the interface you want to use. Once this is done, all the interfaces are listed. And we see that the interface VLAN 0 has changed to VLANsmon. This is because the name is modified when an interface is in monitor mode. Before starting scans, I always recommend creating a folder for each project or client. In this case, we will use one folder for the entire lab. Let's create a folder named Wi-Fi in the user directory to store all the captures there. In this case, it already exists because I created it earlier. Now we can start scanning. For this, we clean the screen and run airodump-ng with the interface we want to use in monitor mode. Use W to indicate where we want to save the captures and the name of the capture, which in this case is scan. Use manufacturer to get manufacturer information and band ABG to scan both 2.4 and 5 GHz. Simply press enter. Now we make it smaller to see all the information by pressing Ctrl and minus. In this screen we have two parts. The top part shows information about the access points, and the bottom part shows information about the clients. At the top, we have the BSS ID, which is the MAC address of the access point, and the signal strength, which is negative, so the closer to 0 the better, and the number of detected beacons. The number of data packets, the channel used by the AP, the type of network encryption and authentication. Here we can see it is a WPA2 CCMP network with MGT authentication. PA2 CCMP with PSK. We also have an open network, a WEP network, another network with TKEP and PSK, TKEP with SAE, and another open network here. In the upper left, you can see the channel being scanned at each moment, and you can see it rotates. In wireless networks, we can only use one channel simultaneously per antenna. So while we are on one channel, we miss information from the rest, which is something important to keep in mind. With the S key, we can enter sorting mode, and I always recommend sorting by the number of data packets. This way, the networks with the most traffic appear first, and so do the clients. With the Tab key, we enter selection mode. In this mode, when we select an AP, the client is also marked, and we can move with the arrows between the different APs. And with the M, we can change the colors of the APs, rotating through different colors each time we press. And we can see that the clients are also marked. It is important to note that M must be lowercase, because if caps lock is activated, it will not work. In the client section, we can see the BSS ID of the AP they are connected to. If we haven't seen them connected to anything, it shows not associated. Then the MAC address of the client in the stations column, the signal strength, the number of lost packets, and the detected frames. In the notes, if a handshake appears, you would see an EPL note indicating that we have the handshake of that user with the AP they are connected to. Finally, we have the probes column, which indicates the probes detected from that client so far, separated by commas. For example, in this case, we have Open Wi-Fi, Home Wi-Fi, and Wi-Fi Restaurant as 3 different probes. To exit this tool, simply press Q. It asks if we are sure, and we press Q again to close. Now, if we go to the folder where the captures are stored, we can see that these 5 files have been saved by default. We clean the screen, and the first and most important one, which has raw information, is the .cap file, which contains all the detected traffic in raw format. This file can be opened directly with Wireshark. Here we can see the traffic of the 802.11 protocol, which is Wi-Fi, and here, for example, we see the beacon frames from different networks and the communication between networks and clients. If it goes to broadcast, they are beacons to the entire network. If we scroll down a bit, we can see traffic that is not 802.11, like ICMP, which is ping. We can see this without any encryption because open networks, which we have seen several of, send the information without any encryption. There are challenges in Wi-Fi challenge oriented to this attack. But in this capture, being from all channels, we only see traffic from a specific channel when it is being scanned at that moment. So most of the time, we miss information from certain channels we are interested in. To solve this, we have to run the command again, but specifying a single channel to monitor only that one. Let's scan all networks to see a channel we are interested in. Let's focus, for example, on the network Wi-Fi mobile, which is on channel 6, and with the space key, we can enter pause mode, which pauses the output and allows us to copy more easily. We exit airodump-ng and run airodump again, adding C6 to specify the channel. And in these cases, I always also edit the file name to indicate that this capture is from a single channel. Now, as we can see, we only see APs and clients on networks in channel 6. So now we can enter selection mode again and mark the networks we might be interested in, and we can see how their clients are identified below. For example, here we can easily see that Wi-Fi mobile has 2 clients that appear in red, and Wi-Fi guest, which is an open network, has 3 clients that appear in green. We stop it again, and within the Wi-Fi folder we can see that we have more files that increase in number with each capture we execute, so they never overwrite. The CSV, kismet.csv, netxml, and CSV store information about the traffic already filtered by the program, but in general we will never use these files. However, we can process all these captures with Wi-Fi DB, which is already installed in the lab, a Python script that processes all these files and creates an SQLite database to merge multiple captures from different moments and different channels into a single database with all the information there, so it's easy to consult and all together. The operation is simply to run the Python script, indicate the name of the database we want to use, and the path where our files are located. In this case, the Wi-Fi folder we created initially. If we pass the whole folder, it looks for all the files it can process and processes them one by one, although this can take several minutes. Alright, it is finished, and it tells us it has been saved in this database, and we can use the SQLite browser to see it in the graphical interface. This opens the SQLite browser with all the tables and views generated. If we go to browser data at the top, we can see all the information organized. Here, for example, we can see all the information about the APs. Okay, we can reorganize the table a bit. We can filter by entering any text in the first column. For example, we can filter everything that contains Wi-Fi. Then we have a column with the detected manufacturers, the channels. And at the end, we have, for example, MFP management frame protocol if it is capable and required. In this case, for example, we can filter to true the requirement and see that Wi-Fi management has it enabled. We also have all the information about the clients, a relationship between clients and connected APs, where it shows which clients are connected to which APs. We also have the processed files. If there were handshakes, they would appear here to crack directly. In identity, if there were user names from MGT networks, they would appear here. We will also see this in the record section. Here we have the probes of all detected clients along with their manufacturers. And here, which of these clients with probes are connected to a network. So we could see that a Wi-Fi global user has 3 probes. That could be relevant information for some attacks. We also have a log of when each AP and each client was seen, and a summary of the detected APs, the number of clients for each, the number of APs, etc. And with this, we have seen the entire database and all the recon and information gathering from those captures. I wish you good recon.